to my lecture today. Of course, today the focus is going to be on main effects and interaction. You know, the other time we started multiple linear regression model. And of course, the multiple linear regression model, we actually considering situation where we're going to have more than one explanatory variable. Okay, what we did the other time was we only focus on main effects. But what we want to do today, we're going to focus on both main effect and interaction. What is the significance of interaction in a multiple linear regression model? That would be what we're going to focus on today. Okay, so that's what we're going to give me 1 second. I think it's telling me she's working now. Yep, I think it's working now. Initially it was not. Okay, so like I said, the focus is going to be on main effect as well as the interaction effect. So I'm for first walk you through, of course, before you interpret linear regression parameters, whether main effect or interaction effect, we need to first estimate, right? We need to first. So because of that, I'm going to walk you through estimating main effect and interaction. And I'm also going to walk you through how to interpret main effect and interaction. Now, I want us to start with example. Okay, we're actually starting with example. We want to explore relationship between age and travel expenditure. Okay, you work for a travel agency, or a travel agency has retained your services to help them, better understand the relationship between the amount spent on traveling last year and age. This is the assignment given to you. Okay. Now, if this is the assignment, but we have two customer segments, which is more or less like additional variable that is going to tell a reason why people travel. Some customers travel for adventure, and some actually travel for culture. No, maybe they want to have a culture at all. Now, I needed to look at the framework of the data. Okay, the first column is the amount spent on travel. The second column is the age. And the third column is categorical variable that tell us the reason why they travel. Okay, don't forget, we're interested in relationship between two variables, amount spent on travel and age. But we realize that, just like what we did the other time, there's a particular covariate that is also important that may influence the relationship between amount spent traveling and age, which is segment. And there are two segments. Okay, now I needed to take a look at this guy now. Now, if I decide to have a plot, don't forget, when we are generating plot, before we start, before we specify any statistical model to capture a relationship between variables, we normally start with a scalar plot, right? Why do we need to do scalar plot? Is just to have a sense of the relationship, whether it's going to be a straight line or not. It's not only straight line that we're looking for. I wanted to take a look at this. This is like showing an interaction. We plotted amount spent against age, and reason why they travel. The one in A, that black one, is those who travel for adventure, A. Why the C, the other color is culture, those who travel for, and you can now see that they don't have the same, even though they have they have straight line, but not the same direction. Can you see that? You see something like an X, right? Which is suggesting to you there may be interaction. Okay, maybe we should consider interaction effects. Okay, now I need you to take a look at this. Let's say, for instance, if you decide to ignore that and you only focus on effect of age on the amount spent traveling, you're going to find yourself fitting that model, right? And in fitting that model, what you're basically going to have in terms of the relationship, you know, it's a write down the fitted model of model 1, right? The fitted model of that is just going to be amount cap. Okay, the amount cap equal 957.9103 minus 1.1140H. This is a fitted model. But let me ask you this question. Can this model explain? Take a look at the next question that I asked. I said, based on model 1, how does age relate to amount for customers in segment A? Can I use this to answer that question? No, because there's no variable segment. No, considering simple linear regression, okay, you did not adjust. You believe that segment may not play a key part, may not play a key role, and that you don't consider it. But you know what? If you don't consider that, if that segment is the one that influence relationship between these two variables, because at times the relationship between this guy and this guy may be influenced by a particular variable that you don't talk about, that you don't even capture. And what will happen when you do that? Then it means you're actually going to mislead. Now, the model on the board cannot answer the next two questions. It cannot answer a question on how, how does age relate to amount for customers in segment A. You know what this particular model is suggesting? It's trying to suggest that they relate the same way. Whether you are in segment A or you are in segment C, the way age relates to amount is the same. That may not be true. From what we've seen here, look at the plots. And because of that, and they are not asking you, is a model 1 a good fit to the data? It may not be a good fit because an important variable is missing. Okay, now because of that, we now added segments. Look at how many variables do we have now on the predator side. We got age, we got segments, right? Okay, but right now we can answer a question, based on the new model that we have. Okay, the new model that we have now is now going to be amount cap. Okay, the amount cap is equal 963 points, 963.4254. Okay, minus 1.09 39. Okay, age. Okay, minus 12.9291 segments. Segment C. Now, this is a new model that we have. But let me ask you this question. Why, we got segment A and segment C, right? But the one in the outputs is segment C. You know what that means? Can somebody tell me? What is R telling us? Like, you have the segment, you have segment A and segment C, and R is reporting only segment C. So what was the assumption? Can somebody tell me for extra credit? No, what I'm trying to say is that you can see that in the output, right? Do you see the output? You see segment C, right? So, and despite the fact that we're focusing on 2 levels of segment, but the arrow is reporting 1. So why? My question, okay, go ahead. Oh, you are very close. You mentioned something 0, 1. This is what happened. I'm going to give you half extra credit. You can send message to me. What happened is when you are talking about categorical variable, right? That has levels. How many levels? 2, right? If arrow automatically reports 1, then he has coded this guy as 0 and coded the one he reported as 1. Does that make sense? You know, you can see segment C, right? In the output, right? Arrow software has automatically coded segment A as 0. Why? It's not as if this is greater than this. This is just for labeling. The one that is coded as 0 is using that as reference. You're going to use that as reference. Does that make sense? Now, if I, this is a module now, right? Now, do you know, based on this general module, I can answer a question. Look at the next question. Based on MOD2, how does age relate to amount for customers in segment A? You know what I'm going to do here? For customers in segment A, I'm going to plug in 0. Anywhere I see segment C. When I plug in 0, what do I have now? This is half. I'm only going to have this guy. Any question? Now, look at the next question. Based on MOD2, how does age relate to amount for customer in segment C? I'm going to plug in 1. I'm going to plug in 1 here. I'm going to plug in 1. When I plug in 1, okay, I'm going to have a new intercept because it's going to be this minus that. Okay, I'm going to have a new intercept. Does that make sense to you now? So anytime, always make sure you pay attention to to the arrow outputs, particularly when you have a predator that is categorical. The one arrow reported is the one that coded 1. The other one that I did not report is being coded as 0. Now you can answer those 2 questions. Now is module 2 a good fit to the data? Of course, this is going to be better than module 1, provided segment is significant, like it can influence relationship between amount and between the response and the predator. But let me tell you this, here we are still considering May effects. We have not considered interaction. Do you know the only improvement here, right? The only improvement is just like, this is similar to what we did on Monday when we are talking about relationship between salary and marital status, when we also put into consideration years of education, years of experience. We didn't do interaction, right? But the only improvement here is just that we are, in an attempt to look at the relationship between amount and age, we are adjusting for segments. That's what we did. That's just an adjusting. Okay, but that may not solve the problem. You know what we want to do now? Look at that code. Age multiplied by segment. That's what we mean by interaction. What is the meaning of interaction? The interaction is the one that is going to tell us the way, the rate, the relationship. It means age, the relationship between amount and age is being influenced by another variable. That is what interaction is coming to do. This is different from what we did here. You know what we just did here? There's no any interaction here. We were only adjusting. That was what we did on Monday. We were adjusting for, what is it called? We're adjusting for segments. Why we still pay attention to age, how age relates to amount. But right now, we are now using the product, which means in a linear module now, we are incorporating a nonlinear effect because we are multiplying age and segments. Take a look at that. Now, let me tell you this. The other time, when we were working on this, you're basically going to see it is not as if, the only thing that we did here, we only adjusted. We only adjusted for segments. The facts remain. We are still talking about relationship between amount and age. Why we are adjusting for segment. That is different from situation. And when we adjusted for segment, you know what happened? When we adjusted for segment, whether you plug in 0 or you plug in 1, can somebody tell me what will happen to the slope of age? It's still going to remain the same. The slope doesn't change. Okay, the interaction needed to be involved. Okay, when interaction is involved, that will change the slope. And what do you see here? Of course, in the diagram, that's a different slope. One is going to be positive, the other one is going to be negative. Take a look at that. You see that? One go this way, the other one go that way. Which means we don't expect the same slope. And the only way to guarantee this different slope is to go by way of interaction. And that is why you see me now, age multiplied by segment. That's all we incorporated. Now, let us now write out the new module. You're going to see what I'm talking about. If I want to write out the new module now. Now, writing out the new module, okay, when we consider interaction now, okay, amount cap, okay, the amount cap equal 962.3315 minus 2.3358, okay, plus 2.2419H star segment C. This is our new model. Now, let us, okay, go ahead. Yeah, this is one of, here I consider main effect of age and interaction. In another module, I can do main effect of age, main effect of segments, and interaction. No. It doesn't really matter, because you know what is on the board. What is on the board is like, let me first look at, if where the primary variable of interest was age, right? Now that was number one. You see age, main effect. Then the new thing that is coming now is the interaction between age and segments, right? Now that is what we brought in now. Did you see that now? Okay, now there could be possibility of so many other modules that we can think of, but to start with the interaction, we can first look at the main effect of primary variable of interest, which is age. Then we look at the interaction of that age and the segment, because people travel for different reasons. Now, do you know what I have now? This is a new module. If I want to answer the next question, say based on MOD 3, how does age relate to amount for customer in segment A? Now, for customer in segment A, we're going to plug in 0 here. I told you, why do we see segment C in our arrow output? Because arrow automatically, whatever you see in your arrow output, when you are dealing with a categorical variable, is what arrow coded as 1. The other level that you don't see, arrow coded that as 0. Now segment A, I'm gonna plug in 0. Now when I plug in 0 here, the whole of this is gonna be what? 0, right? What is gonna be the new module now that I'm gonna be using? It's just gonna be this guy. So for customers, okay, in segment A, the new model is going to be amount cap equal 962.3315 minus 2.3358H. What is the difference between this and this? Do you know that they still have the same intercept? Right? But let us now answer questions. The next question. Based on MOD, how does age relate to amount for customer in segment C? Now we want to plug in 1, right? Now, if we plug in 1 here, okay, now for customers, okay, in segment C, now amount cap is going to be 962.3315 minus 2.3358H plus 2.2419H1. 1 represents segment C. What is going to happen now? Don't forget 2.24H. This is another H. You know what is going to happen? The slope of H will change. Does that make sense? The slope of H will basically change, which means the slope here for customer A is different from the slope for customer C. Does that make sense to you now? If you take a look at the two, okay, the slope for customer A is negative, but for customer C, you know, if you do 2.24, maybe probably you're going to get something. So here now, they're going to have a different age. Okay, so I wanted to take a look at that. Now, this is another one I talked about the other time. Somebody can say, okay, let us have a way of improving on this particular model, because in this model, we only consider main effect of age. Can we also adjust for segment? You know, when you are adjusting for segment, it means you also want to consider the main effect of segment. And in addition to that, you consider interaction. That is what we actually want to do here. What do you see? Age, main effect of age, main effect of segment, as well as their interaction. This is a full model. This is a little bit better than this one. Okay, take a look at this now. Okay, now if I write the new model now, okay, you're basically going to see, you know, I'm going to write a new model how, so that you will see what I'm talking about, because, you know, I can have all this in exam. Let me just be taking 2 decimals so that I don't waste time. Amount now, right? What is the intercept? I want to write the general model 1814. Let me just take to 1 decimal 0.5, right? Minus 20.3 H, right? Minus 1821.2 segment C, okay? Plus 40, plus 40.4 H cross segment C. Now, do you see the full model now? Okay. Now, how do we answer the next question? Based on module 4, how does age relate to amount for customers in segment A? For customers in segment A, anywhere I say segment C, I put 0. For customers, don't forget, for customers in segment A, we don't set segment C to 0. Now, when I say segment C to 0 here, the whole of this is 0, right? Segment C to 0, the whole of this is 0. What am I going to have? I'm only going to have this. I'm only going to have this. But let me tell you this. if I want to do for customers, okay, in segment C, when I plug in one here, okay, in that one, I'm going to plug in one here, plug in one anywhere I see segment C, I'm going to plug in one. Now, when I plug in one, what is going to happen? When I plug in one, the intercept will change. When I plug in one, the slope will change. Slope and intercept will change at the same time when you consider main effects of this, main effect of that, as well as their interaction. Because if you take a look at this guy here, do they have, look at this shape, do they have the same intercepts? They don't have the same intercept, they don't have the same slope. Okay. Now, these are the possibility of models we have already considered. But the next thing I want to talk about now, how do we interpret? Because the most important thing is interpretation of results. And we basically want to start with model 2. What is model 2? Model 2 is multiple linear regression, where I'm looking at the effect of age on a month and I'm adjusting for segments. Here, do we see any interaction in this one? This is the one, this is more or less like the one that we did on Monday, where we have one variable and we are considering that variable in effect of that variable in the after adjusting for another variable. Here now, if you look at what I'm showing you now, okay, we're looking at the effect of age on the amount spent, okay, on travel, and we are adjusting for segments. Now, how do we interpret? We're always going to start your interpretation with the intercept, whether it makes sense or not. Now, technically speaking, in mathematics, intercept is the values of y when s equal to 0, right? Now, in this context, when s equal to 0, don't forget, what is our x? S is age, right? S is age, right? And we have 2x, okay? When you take a look at the input, how many input? Age and segment, right? And when the values of y, when all input is 0, when age equal to 0, and for segment A, why segment A? Because segment A is coded 0. How do I know segment A is coded 0? Because in my output, what do you see? Segment C. Whatever you see in your output is coded 1. Then the other level is automatically coded as 0. Any question? Now, you know what I'm trying to say now? The amount that we spend on average when age equal to 0, and if the customer travel for adventure. And that was what I put here. Customers in segment A who are 0 spend $968.4 in traveling expedition on average. But that is not meaningful, right? Even though it is not meaningful, we have to state that. Because it's like they are more or less talking about a baby. A baby that is less than 1 year of old. You get what I mean? So, and they travel for adventure. I want to believe that baby can't travel alone. You know that, right? Okay, any question about the interpretation? Do you know what we just interpreted here, right? We started with intercept. Now, okay, go ahead. That's a very good question. You don't have to. R will automatically decide for you. That's a good question. Yeah, that is when you want to do it on your own, but that is the essence of the R. If what you see in your code, I mean in your output, at time, if I see segment A, then I have to know that whatever I'm going to be writing is going to focus on segment A, which means that segment A is coded 1. So how do we automatically do that for you? Automatically. That's a good question. Okay, now we have interpreted intercept, right? Then we need to also interpret, there are two slopes, right? There are two slopes, one for H and one for segment C, right? We've already interpreted the intercept, right? Now, we want to start with the segments. Don't forget, you remember what we said on Monday, all right? When you have two explanatory variables, if you want to interpret slope associated with one, you have to say you keep other at constants, or you say you adjust. Look at that. It said holding H constant. Why do I say H constant? Because I want to interpret the slope associated with segments. So holding H constant, the customer in segment C, you have to mention the one you see in the outputs. The customer in segment C spent $12.9 less. Why is it $12.9? Spend $12.1 less on average than customer in segment A. Look at that. Than segment that customer in segment A. I told you when I coded a level as 0, you're actually using that level as a point of reference. Any question on this interpretation? We don't just analyze in statistics, but you know what is very, very crucial? Interpretation of results is very, very crucial. Because this is where your managers are waiting for you. Maybe your manager, they don't know, they don't even understand statistics at all. This is where they're going to be waiting for you. Any question on this one? Now I want to go interpreting age. Now, don't forget, there are two slopes. Now, you know what I want to do now? I want to interpret slope now. I'm also going to say the same thing. When I'm interpreting slope, I have to keep segment at what? At constant. And that was why I said for customers in the same segment, anytime I want to refer to age, don't forget age is continuous. The other one that we interpreted the other time, this was a categorical predator. When you are interpreting categorical predator, you're actually going to do what? You're actually going to relate. You're going to relate that to the one arrow coded 0, which is segment A. You are actually interpreting that relatively. That was why you mentioned only here customers in segment C, right? Customers in segment C compared to segment A. But right now, what I'm interpreting is a continuous predator, not categorical. Look at that age. Age is continuous. It's not categorical. All what I'm going to do, and when I'm interpreting continuous predator, and I have a categorical predator along, I'm only going to say for customers in the same segment. Increasing the age by 1 will lead to $1.1 reduction. Because of that, look at that, negative 1.09. I actually round that off to 1 decimal. Any question on this interpretation? Please pay more attention to the way we interpret, particularly when you got two variables that are explanatory variables. One is continuous, the other one is categorical. If you want to interpret the categorical one, you need to mention what you see, segment C, in relative to segment A. And you have to say you are holding the other predator at a constant. Now, when you want to, when you get a turn, interpreting, the slope for continuous variable age, or what you're going to say for customers in the same segment. Okay, so take a look at that. Now, I want to go into another interpretation now. This is the one I call the standard model, right? Where we're basically going to consider the main effect of age, the main effect of segment, and their interaction. Of course, take a look at this. This model here, extension of this model is this one. This is an extension. The only difference between model here and the only difference between model 4 and model 2 is because you are adjusting for segments. Look at that. That is the difference between them. Now, there's something I want you to see. Adding main effect of segment, like why, initially, do we add the main effect of segment here? No. Initially, it was just the primary variable of interest, age, and the interaction. Now, adding the main effect of segment, what is the contribution? So adding the main effect of segment allow the intercept to change. Why? Why do you want the intercept to change? Because you've already seen that in the picture. Because you see that this does not have the same intercept. Does that make sense, right? Because you want the intercept to change, just like what I demonstrated the other time. And adding the now, what is the essence of adding the interaction? Adding the interaction, age, and segment allow the slope of A to change for each category of segments. One effort will lead to a change in intercept. The other effort will lead to change in slope. As you can see in the picture, they don't have the same slope. They don't have the same intercept. Now, how do we interpret this? This is the one we're talking about. Okay, how do we interpret this guy now? Like I said, your interpretation must start with the intercept. How do I interpret intercept that I'm seeing now? 1814.5445. It's still going to be the same interpretation. The average travel expedition for customers who are, I'm still going to say 0 years. What is missing there is 0. 0 years, hold, and in segment what? Can somebody tell me? Is it segment A or C? Hey, good job. Segment A. Because I'm talking about intercept. Because my R coded segment C1, how do I know? Because segment C is what is appearing in my output. Automatically, segment A is 0. Any question on that? Now, let's see how we're going to interpret the age now. That negative 20.3. Okay. Now, if I want to interpret age, I say for customer in segment what? Is it good when I plug in 0 here? What I'm still going to have is going to be, the slope is going to be negative 20.3. And that's why I'm plugging in 0 means I'm focusing on segment A. She's right. No, it's going to change. It's going to change. When you put 1 here, look at this age here. Exactly. And that is what now you get, you can see the benefit of maths. You know why I reason with you? I reason because of maths. I discarded theory. Yeah, maths is good. Now, because of my time, now take a look at this. The average travel expedition for customers who are dash years, of course, I'm back at interpreting intercept, right? Of course, this one is going to be 0 and A. Intercept is easy. You know that, right? Now, coming to, oh, wait a minute. I think I came back. It's supposed to be the last one. Okay, I should be here. Now, we've done that of intercept. We've done the slope for age. We want to do that of the segment C now. But let's go into theory. What did the theory tell us? Why are we adding segments? To allow the intercept to change. Do you see that? Adding main effect of segments allows the intercept to change for each category of segments, right? Now, you have to put that into consideration. Now, take a look at this now. Technical interpretation. The difference of intercept in the filter model for the 2 segments. Does that make sense? Because different. You can only measure different when something change. Any question? Good. Now, interaction. Let's see what the theory talk about interaction. Leave math now. What does the theory talk about interaction? Interaction will allow the slope to change. Even when you look at it mathematically, okay, it's basically going to allow the slope to change. Okay, now, in that situation, he said the difference in the slopes of age in the fitted model for the 2 segments. We're done. Any question now? So in the interpretation of, this is it. When you look at the role played by interaction, the role played by interaction is that, oh, we want our slope to change. The role played by effect of segments, oh, that will make our intercept to change. That should reflect in our interpretation. Any question? Now, this is how we do that. This is how we actually, now, technically speaking, if you want to consider the interaction in your model, most of the time, our models are not failing us, except that we don't really try to, we don't use the right model. There are situations whereby we're looking into a relationship and there may be interaction. The idea behind interaction is just like the rate at which one relates to the other depends on another variable. But let me tell you this. Our interaction needs to be significant. How am I going to know? I needed to pay attention to the p-value of the interaction. You can see it's very, very small. The only condition, see, forget about the graph at times, forget about what you are saying. That's the only condition to justify inclusion of a particular effect, whether main effect or interaction effect, is when the p-value is less than a given level of significance. I'm going to say that again. When the p-value of an effect, whether main effect or interaction effect, before we can tolerate that in our model, then the p-value has to be less than 0.05 level of significance. That is what we call statistical significance. That is the only way to investigate. And that would now justify including that in our model. Otherwise, if it is not, we don't need it. Do you know that there are some researchers, because they want to play to gallery, for simple relationship, for data set or variable that require simple relationship, they will be using complicated model. That will go nowhere. But what is the only way to tell? By way of conducting statistical significance. So which is what the p-value is going to tell us. If you look at this final model now, all the effects are what? Significant. Look at that. Look at the p-value. They are all significant because the p-value is less than 0.05. Any question? How is today's topic? Kind of. Okay, go ahead. No. When the p-value is less than alpha, when the p-value is less than alpha, then that justifies inclusion of that effect. It means that effect is, we need it. It should be in the model. Exactly. That's what we mean. But how are we going to know? We try different kind of models. But, as time goes on, that is not the only way. That is not just p-value associated with that. We also have other evaluation mechanism that I'm still going to be showing you in this course. Now, I want to say something about midterm 1 before I go. Do you know that the current assignment and the assignment that you have done, that is going to reflect midterm 1. Whatever the midterm 1 is going to cover everything that we started up to this week. Up to this week, like Friday. But you know what? I'm going to release, you're still going to see midterm. Now I can release midterm 1 practice question now. You know why? Because it will cover everything that we did from the 1 to this week, Friday. Does that make sense? Okay. Any question before I go? Do not forget to send me a message for extra credits for something you corrected the other time, right? About the segment, so that your class is going to get one point of extra credit. Okay, bye for now, everyone.